Pluto is a distant and mysterious celestial body. Once part of our solar system's global family, it has recently returned to the public eye due to alarming statements from well-known astronomers such as Neil deGrasse Tyson and Michio Kaku. They've developed a shocking theory: Pluto might be on a possible collision course with Neptune. But how could such an incident occur? And what would happen if it did? Is this a rare anomaly of the universe, or is there more to this potential cosmic event? Join us as we investigate the possibilities. Pluto was once classified as a planet, but it was later renamed a dwarf planet because of its unusual orbit, which continues to captivate the scientific community. According to recent research by eminent scientists, Pluto's course is dangerously close to the orbit of Neptune. Famous astrophysicists like Neil deGrasse Tyson and Michio Kaku are raising concerns about the possibility of a disastrous event, a scenario that might be a serious threat to Earth. But how could such an occurrence actually happen? Pluto's tour around the Sun is extremely unusual, requiring a remarkable 248 years to complete a single orbit. Since its discovery in 1930, Pluto has only completed one full orbit, which enhances its mystique. Not only is Pluto's orbit slow, but it is also extremely elliptical, vastly different from the orbits of the larger planets. Further complicating things is the tilt of Pluto's orbit. It is angled 17 degrees with respect to the solar system's plane. This tilt makes its path significantly more extreme than that of other planets, introducing new levels of complexity. One of the most intriguing aspects of Pluto's orbit is its interaction with Neptune. For approximately 20 years during each of Pluto's orbits, it is actually closer to the Sun than Neptune, defying our expectations based on their relative positions in the solar system. This naturally raises the question: why hasn't Pluto collided with Neptune? The solution lies in the gravitational influences of other celestial objects, particularly the vast planets. Pluto's orbit was studied shortly after its discovery, and its strange path baffled astronomers. Unlike the nearly aligned orbits of other planets, Pluto's orbit stood out due to its elliptical shape and steep tilt. Awareness that Pluto's orbit crosses Neptune's was a major scientific focus. Despite these irregularities, Pluto's orbital stability is an extraordinary aspect of space mechanics. Here, the phenomenon known as the three-body problem comes into play. This issue, studying the motions of Pluto, Neptune, and the Sun, requires understanding how three celestial objects influence each other via gravity. Predicting their paths is a difficult task. This is where terms like scope libration and VZK wobbling become relevant. Scope libration refers to how Pluto's orbit behaves as it moves vertically relative to Neptune's. When Pluto approaches Neptune, or any other massive planet, it is elevated above the plane of their orbits, providing additional protection against potential collisions. The term VZK wobbling is derived from researchers VZ and K, who studied gravitational interactions in space. This wobbling sheds light on how Pluto, Neptune, and the Sun's gravitational pulls influence one another. Despite its apparently erratic behavior, Pluto's path remains stable due to this wobbling mechanism and other complex gravitational forces. These movements unfold over extended timescales, ensuring Pluto's orbit avoids collision with Neptune. The three-body problem is crucial for understanding gravitational interactions among multiple objects. It enhances our understanding of Pluto, our solar system, and distant celestial bodies. In the late 1980s, mathematical simulations of star behavior showed that, although Pluto's orbit contains stabilizing factors, it still remains inherently chaotic. Minor adjustments to its initial conditions could result in significant differences over time. Despite this, Pluto's orbit has remained stable over extremely long time intervals, efficiently avoiding major disturbances. The most recent computer models provide new insights into how gravitational effects from giant planets like Jupiter and Saturn affect Pluto. These models reveal that Neptune has completed 3 orbits for every one of Pluto's, a unique relationship that helps maintain Pluto's stability. However, forces beyond Neptune also play a role. Jupiter's gravity, in particular, is strong enough to help guarantee Pluto's orbit remains stable for billions of years. Saturn and Neptune, together with Jupiter, form a collaborative system that keeps Pluto safe from significant collisions. If these gravitational forces were disrupted, our solar system would become much more chaotic. Dwarf planets like Pluto and others might collide or be flung from their orbits. Thus, comprehending Pluto's orbit is essential. Pluto's dynamic orbit is a perfect illustration of how even unstable-looking paths can achieve long-term stability through the complex interaction of gravitational forces. It also emphasizes the need for continuous investigation to understand our universe. Pluto's orbit shows the unpredictability of celestial mechanics and the concept of orbital chaos, which refers to how sensitive a body's orbit can be to even the smallest changes. Simulations of Pluto's orbit over time reveal how a tiny shift in its position or speed can dramatically alter its trajectory. These simulations play a key role in helping researchers understand how Pluto moves. The models use intricate mathematics to simulate the gravitational interactions between Pluto and other bodies. Astronomers can tweak small variables to observe how even minor changes can significantly alter Pluto's long-term orbit. Late 1980 simulations revealed that, while Pluto's orbit could be stabilized through mechanisms like AIML scope calibration, it still shows signs of minor instability. Variations in Pluto's initial position or speed can lead to large orbital shifts over time. Despite its apparent chaos, Pluto's orbit remains relatively steady for billions of years. This demonstrates that, although its course may look erratic, a fundamental order keeps it on track. However, these chaotic orbits are notoriously difficult to predict. The slightest inaccuracy in initial measurements can lead to dramatically different results, making long-term predictions nearly impossible. Pluto's orbit serves as a reminder of how dynamic and ever-changing the universe is. Even as we make great strides in space research, Pluto's orbit reminds us how much remains unknown. The gravitational interactions between planets offer insight into the larger dynamics of the solar system. Each planet's position can have profound effects on the stability and trajectories of others. This is why astronomers are expressing concern about a possible Pluto-Neptune collision. Neil deGrasse Tyson, a well-known physicist and advocate for public science engagement, offers insight into Pluto's classification. He views Pluto's reclassification as a dwarf planet not as a demotion, but as a refinement of our understanding of celestial bodies. Tyson emphasizes that Pluto's erratic orbit indicates there's much more to discover in space. The possibility of a catastrophic event, however remote, continues to captivate researchers and the public. Michio Kaku, another renowned physicist, adds his voice to those raising long-term concerns about Pluto. His theoretical work delves into the mathematical underpinnings of Pluto's potential interactions with Neptune. This is why continual observation and simulation of Pluto's orbit remain critical. Modern telescopes, like the James Webb Space Telescope and ground-based observatories such as the European Southern Observatory's Very Large Telescope, are instrumental in tracking tiny changes in Pluto's position, speed, and trajectory. With every passing year, astronomers refine their models, aiming to predict any deviation that could suggest long-term instability. Additionally, space missions like NASA's New Horizons, which flew by Pluto in 2015, have provided invaluable data, not just about Pluto's physical features, but also about its interactions with the outer reaches of the solar system. From surface geology and atmosphere to magnetic influences and interactions with the Kuiper Belt, every detail helps deepen our understanding of this elusive world. The Kuiper Belt itself adds further intrigue to the conversation. This vast, donut-shaped region beyond Neptune is home to thousands of icy bodies, many of which follow orbits just as eccentric and tilted as Pluto's. In fact, some scientists speculate that gravitational nudges from Kuiper Belt objects, or even a hypothetical Planet 9, could subtly influence Pluto's long-term path. While these effects are minor in the short term, their impact over millions or billions of years could be significant. What happens, then, if these forces eventually shift Pluto onto a new course? While a direct impact with Neptune is unlikely under current models, a close gravitational interaction, what scientists call a near pass, could result in one of several outcomes. Pluto might be ejected from the solar system entirely, becoming a rogue planet drifting alone through interstellar space. Alternatively, its orbit could be altered enough to cross paths with other celestial bodies, posing new dangers not only for Neptune, but potentially for the inner solar system as well. Even now, cosmic collisions aren't just theoretical. Astronomers have witnessed the aftermath of such events in other star systems, dust clouds that hint at shattered planets, disrupted orbits, or even massive gravitational slingshots flinging objects into deep space. Within our own solar system, the scars of ancient impacts are evident on moons, planets, and asteroids. Pluto's history likely includes such collisions, given its battered surface and the presence of its largest moon, Charon, which may have formed from a massive impact. This brings us to an even deeper truth: the solar system is not a static, peaceful clockwork. It's a dynamic, ever-changing arena of motion, chaos, and balance. What appears stable on human timescales may be teetering on the edge of transformation over cosmic epochs. Yet, there is beauty in this chaos. The ballet of gravitational interactions, Jupiter shielding Earth from deadly comets, Neptune maintaining a delicate dance with Pluto, and the Sun orchestrating it all, shows us a universe of exquisite balance, where even danger contributes to harmony. These forces have shaped planets, moons, and entire systems. They may one day shape our fate, too. That's why Pluto's story isn't just a tale of a lonely dwarf planet. It's a reminder of our place in the cosmos, a planet orbiting a star, among other planets, all bound by invisible threads of gravity. It's a warning and a wonder. The universe is both fragile and fierce, predictable and mysterious. And so, as we look skyward and continue mapping the stars, we remain humbled by the vastness of it all. Pluto will continue its slow, tilted dance around the Sun, watched closely by astronomers, loved by dreamers, and studied by scientists hoping to unlock the secrets of the universe, one orbit at a time. Space remains our means of reaching space exploration, which has provided us with methods of simulating and better anticipating and observing cosmic phenomena that have the potential to collide. A close call between Neptune and Pluto remains an impressive illustration of the complexity and erratic nature of our solar system. While it is difficult to determine whether such an event ever occurred, its possibility emphasizes the dynamic nature of our cosmic environment. The orbit of Pluto inspires us to look beyond what we already know and to accept the mysterious nature of space, which forces us to adopt new perspectives and remain open to surprises that scientists may discover. Continued exploration into the mysteries of the cosmos serves as a reminder that we have merely scratched the surface of what the universe has planned. Whether Pluto and Neptune will maintain their safe orbits or encounter a cosmic collision one day remains an unanswered question, one that only time and new discoveries will resolve. As we advance in our understanding, the story of Pluto's orbit serves as a representation of the mysteries that continue to confuse and thrill researchers. The possibility of a collision or a close call between Neptune and Pluto, though unlikely to occur anytime soon, is a reminder of how much more we have to discover about the vastness of space. These celestial events, regardless of how distant or improbable they may seem, invite us to keep asking questions about the fundamental forces at play in the universe's ever-expanding field of astronomy. There is always more to learn. As we proceed to investigate space, exploration tools and techniques for studying far-off worlds like Pluto continue to advance. Sophisticated space telescopes, missions, and powerful computer simulations now allow researchers to study celestial objects with unprecedented precision. These innovations provide fresh perspectives on the mechanisms behind planetary gravitational interactions and long-term orbital stability. One of the most exciting advancements in the study of Pluto and its orbit is the progress in observational technology. New space missions are frequently launched to examine distant regions of the solar system. The findings of the New Horizons probe, for example, have provided critical information about Pluto and other Kuiper Belt objects, offering a more detailed view of these faraway worlds. With each new discovery, our comprehension of these bodies becomes clearer and more illuminating. Pluto remains an object of curiosity and scientific inquiry, even after its reclassification as a dwarf planet. This change in status has not ended our fascination with Pluto. On the contrary, it has sparked ongoing public debate about what defines a planet and emphasized the evolving nature of scientific understanding. Pluto's path reminds us of the fluid nature of science. What we know today may change tomorrow as new hypotheses emerge and new data is collected. Some have even suggested the possibility of a future Pluto-Neptune collision, not as an imminent event, but as a theoretical possibility that reflects the broader unpredictability of space. Because of space's chaotic nature, even the most stable systems can experience sudden, significant shifts. Scientists study the relationship between Pluto and Neptune not only to understand the dynamics between these two bodies but also to deepen our overall comprehension of how gravitational forces shape the motion of every celestial object. The lessons from such studies have far-reaching implications, not just for our solar system but also for our understanding of planetary systems throughout the galaxy. The examination of Pluto's orbit also highlights the importance of collaboration. Astronomers, astrophysicists, mathematicians, and physicists bring their expertise together to analyze Pluto's motion. This cooperation has led to more precise models and a deeper understanding of the delicate balance that ensures harmony within our solar system. While the idea of Pluto colliding with Neptune may seem far-fetched, it symbolizes the ongoing challenges in predicting the behavior of distant celestial bodies. The universe's chaotic nature means that even minor objects can significantly affect larger systems. The story of Pluto and its potential interaction with Neptune is not just about two distant worlds, it represents a larger pursuit of understanding in astrophysics. No matter how much we learn, there is always more to discover. The universe is full of surprises. As technology evolves, we will continue to uncover its mysteries, one revelation at a time. Though the idea of Pluto coming close to Earth or Neptune is unlikely, it serves as a powerful reminder of the mysteries that still lie ahead in space exploration. Pluto's future orbit remains uncertain. We must wait and observe how cosmic forces will shape its path over time. One thing remains constant: the more we understand Pluto, Neptune, and the universe, the more we realize how much more there is to explore. As we continue to study Pluto's evolution, the effects of gravity on other worlds, and the intricacies of orbital mechanics, we are reminded of the universe's vastness and complexity. Pluto's story is far from over, and each new discovery brings us closer to understanding its true role in the solar system and the broader universe. The gravitational interactions between Pluto, Neptune, and other solar system bodies illustrate the complexity and beauty of the universe. While a collision is distant and unlikely, the ongoing investigation into these distant worlds continues to engage both scientists and the public, offering valuable insight into the universe's deepest mysteries. Space may be vast, but each new discovery brings us closer to understanding everything. Every breakthrough in space science pulls back another layer of the cosmic curtain, revealing patterns and phenomena that were once beyond imagination. The deeper we explore, the more we realize how interconnected every element is, from the subtle gravitational nudges between Pluto and Neptune to the broader choreography of galaxies. As we refine our models and expand our technological reach, we begin to grasp the subtle nuances of orbital resonance, planetary migration, and chaotic motion. These are not merely abstract concepts, they are the keys to unlocking how solar systems evolve over billions of years. Pluto's complex orbital dance with Neptune is a living testament to the dynamism of space, a reminder that even on the edge of our solar system, celestial bodies are never truly isolated. Advanced simulations now allow scientists to test countless orbital scenarios, projecting thousands, even millions, of years into the future. These models are not just about predicting potential collisions, they are about understanding the long-term stability of planetary systems. They challenge our assumptions and sharpen our scientific reasoning. Moreover, as missions like New Horizons inspire a new generation of explorers, our gaze shifts outward, not only toward Pluto, but beyond, to the icy realms of the Kuiper Belt and the scattered disk. These regions are populated with remnants of the early solar system, holding clues about its formation and the processes that shaped it. Pluto's reclassification as a dwarf planet was not a demotion, but a doorway to richer questions. What defines a planet? How do we categorize celestial bodies in a universe so diverse? These debates have reignited public interest in astronomy and brought scientific discourse into classrooms, dinner tables, and global conversations. What Pluto teaches us, ultimately, is humility. Its story, once thought to be that of a lonely, icy rock, has blossomed into a rich narrative of geological activity, atmospheric complexity, and orbital intrigue. It reminds us that assumptions must always be tested, and that the universe often defies neat categorization. Looking ahead, new missions, such as those proposed to return to the outer solar system, promise to deepen our understanding. Instruments capable of detecting faint thermal emissions, capturing high-resolution imagery, and conducting in-situ analysis could unveil layers of information still hidden from view. But beyond the science, there is a poetic beauty in this pursuit. Pluto, once a tiny dot in a telescope lens, now looms large in the collective human imagination. It symbolizes the frontier spirit of exploration, a willingness to reach further, to ask bigger questions, to dream beyond the limits of our current knowledge. In this grand odyssey, the potential interactions between Pluto and Neptune are more than orbital mechanics. They are metaphors for balance, chaos, and the fine line that separates them. They embody the spirit of inquiry that drives astrophysics forward, day by day, light year by light year. And so, we continue, charting paths through the cosmos, expanding our understanding not only of planets and particles, but of the very forces that shape reality itself. In every equation solved and every mystery unraveled, we edge closer to a deeper truth, that the universe is not only stranger than we imagine, it is stranger than we can imagine.